Good day to Dr. Mazlan bin Mohammed. Our group is proud to present our Capstone project for the BITI2513 Introduction to Data Science course. Our project is titled the IoT Based Counter. My team member is Saiful Izzuddin bin Zaini, Muhammad Nur Muaz bin Amir Hamzah, and my name is Suesa Sikunkel. I will start with the introduction. So at Prime Consumer Malaysia, workers currently count safety pin manually. So this leads to long processing times, worker fatigue, and frequent error. Safety is also major concerns. Our CATIA assessment show a high RULA score of 6, indicating a significant risk of injury due to awkward posture. To solve this, we propose an IoT-based counter. This device automates counting to improve accuracy and, importantly, enable real-time data collection in line with Industry 4.0. Moving on the company backgrounds, we focus on Prime Consumer Malaysia, located in the Tanjung Kling Free Trade Zone. It is a subsidiary of the Prime Group, which is actually Germany's oldest industry company. Established way back in 1530, here in Malacca, there have been producing items like safety pin and needle for over 40 years. Despite their long history, we found that their packaging process is still largely manual. This gap creates a clear opportunity for us to introduce automation and help them move toward Industry 4.0.
Assalamualaikum. Here I want to discuss about the problem statement. For problem statement number 1 is inconsistent counting accuracy. The manual counting on safety pins and needles is highly dependent on worker concentration. During long working hours, fatigue can cause worker to miscount item, resulting in underbaked or overbaked products, which affect quality assurance and may lead to customer complaints or financial losses. So for the number 2 is ergonomic and head risk. Workers are required to bend forward and perform repetitive hand movement when counting small items. Ergonomic analysis using CATIA showed a RULA score of 6, indicating a high risk of musculoskeletal disorders, neck pain, a long-term occupational health issue that can reduce work efficiency. So for the number 3 is lack of real-time operational data. The current process does not include digital monitoring of or data logging. Production data such as output quantity, cycle time, and error rates are recorded manually, preventing real-time performance tracking and limiting the use of data analytics for productivity improvement and decision making. Thank you. That's all for problem statement.
Assalamualaikum warahmatullahi wabarakatuh. I will explain about project objective. The first project objective to reduce processing and packing time. This objective aims to shorten the overall time required to count and package safety pins and needles. By automating the counting process using an IoT-based system, manual handling is minimized, enabling faster, more consistent operation and improving overall production efficiency. Second objective is to reduce the number of workers and workstations. The project seeks to lower the dependency on manual labor by replacing repetitive counting tasks with automation. This allows fewer workers to operate the packaging process, reduce workers' fatigue and ergonomic risk, and enables better workplace allocation to higher value tasks. Next, I will explain about methodology of this project. First methodology is mechanical design and fabrication. The machine structure is designed and built using 10mm plywood. This material is chosen because it low cost, lightweight and easy to fabricate. The second is electronic hardware integration. Electronic components such as Arduino, sensor and motor are installed. Sensors are used to detect safety pins and ensure accurate counting. The third methodology is software development and data logging. Arduino and Python programs are developed to control the system and record counting data. The data is stored for monitoring and analyzed. The fault methodology is system integration and testing. All parts are combined into one system and tested to ensure accurate counting and reliable operation. This slide is for the coding review of our project. The coding review we use is Arduino Uno. We put all the coding in the Arduino, so all of the project can run automatically. Okay, for this slide I will explain about cost structure. The IoT based counter is designed using low cost materials to keep the total development cost affordable. The overall cost of the system is RM246.97. Most of the comes from electronic components such as motors and sensors, which are necessary for accurate counting and operation. The machine structure is made from 10mm plywood, which help reduce fabrication costs while still providing adequate strength. This low-cost design makes the system suitable for small-scale industrial use.
So, for the benefit to the company, standing of currency problems, the report clearly identifies issue the current manual packaging process, such as counting errors, worker fatigue, and ergonomic risks. They help the company understand where improvement are needed. So, for the number two is improve decision making. By analyzing data, workflow, and cost, the report provide useful information that help management make better decision regarding automation and process improvement. So the number three is identification of a low-cost solution. The report shows that an effective to IoT-based automation system can be developed at a low cost of RM246.97, providing that improvement is possible without high investment. For the number four is support for the productivity and safety improvement. Finding from the report highlight how automation can increase productivity while reducing health and safety risks for workers. And the last one is reference for future improvement. The report can be used reference for future upgrades, scaling the system to other packaging lines, and support the company industry 4.0 initiatives.
In conclusion, our IoT-based counter successfully addresses the physical problem, manual counting, and ergonomic risks. However, the most significant achievement of this project lies in the data science application. Through our coding implementation using Arduino and Python, we move beyond simple automation. We successfully create a simple, capable, of digital data logging. Unlike the previous manual method, our code allows the system to capture real-time production data and store it automatically for monitoring. This is crucial because it transforms raw operational activities into valuable data points. This data can now be used for analytics to track productivity, trend, and improve decision making. Ultimately, this project proves that by integrating coding with hardware, we can drive Industry 4.0 implementation at prime consumer Malaysia and neighborhood. Thank you from us.